Well, I'm back to the original basic absolute value function that we began this video with. And this time I want to show you how the horizontal translations work, or horizontal shifts. And so look what happens if I replace x with something a little different here. So let's look at y equals 2, the absolute value of x plus 2. Alright, now intuitively you would probably predict that this should be shifted to the right. I'm adding 2 to the x's. I'm changing the x values by 2 by adding 2 onto them. But as we find out, the effect is actually the reverse. This means a horizontal shift in the negative direction of -2. And we'll see that here pretty well. In this case, these values become, when I plug 0 in, y would be 2. Plug in 1, y would be 3. If I plug in 2, y would be 4. That's 5. And here is, let's see, now if I put -1 in, I get +1. If I put -2 in, I get 0. -3 gives me +1 again. Alright, so how does that pattern run? It turns out that at -2, the graph touches the x-axis. Alright, so x equals, it now requires -2 in order to give me a 0 for a y value. Instead of 0, it takes -2. And if you plot out all these points, you'll see that this graph is runs this direction, and it's been shifted to the left by 2 units. So adding 2 to x effectively shifts it in the opposite direction, in the negative direction. And so here is y equals to the absolute value of x plus 2. Alright, now I prefer to think of it as replacing x with x plus 2. If you replace x with x plus 2, then you have a negative shift of 2 units. Now you notice that appears to be opposite from what we did with the vertical shifts. When I added 2 to the function, I went up, positive. Here I add 2 to x and I go negative. Why is that? Well, let me take a quick detour and explain that. Our original function, y equals absolute value of x, if I were to add 2 to the right side, recall that bumped the function up by 2 units. It was a vertical increase. But if I bring the 2 to the left side and think of it this way, then what we've done is to replace y with y minus 2. So if I replace y with y minus 2, which is the same as this function, in this case, then that results in a positive vertical shift. And if I were to change this to plus 2, that would be a negative vertical shift. So as this plus 2 is a negative horizontal shift. So I want to make that point because this is actually more consistent, actually it's very consistent between the horizontal and vertical shifts. It just may not appear that way the first time you see it. But if you think of it as terms of replacing a variable with something else, then it becomes consistent between horizontal and vertical shifts. Alright, so you might have to think about that a little bit. Somehow you have to keep all this straight. Alright, and that's unfortunately ultimately your problem. Okay, to keep all this straight. That's why you should be taking notes and practicing as soon as you can when you see these videos. And also read my book to reinforce it. Alright, so board's a little cluttered, but let me just write up another one. If I were to draw this absolute value function, what would it be? Well, it's the basic y equals absolute value function, except it's been shifted to the right. So that means that x has been replaced with x minus 1. So replace x with x minus 1, it shifts to the right. Alright, I'm going to erase the board and then talk a little bit more about these translations before we move on to the other kinds of transformations. I wanted to speak a little bit more about translations, geometric translations, and I'll use my book as an example. In geometry, a translation is what occurs when you move an object without rotating it or without any other kind of deformation. In other words, if I take this book and I slide it along the wall here, back and forth, that's a horizontal translation. If I go up and down, that's a vertical translation. I could translate it diagonally. And as you might expect, eventually you're going to have to be able to do all those combinations of translations we're going to talk about, or transformations. So translations never affect the shape of an object in geometry, nor its orientation. For example, if I flip the book over, that would be called a reflection. And so a reflection is a different type of transformation, which we will get to. And then another one, if it was possible, is to stretch it. You could stretch or distort a geometrical object, and we'll study those as well. So those are the kinds of transformations that we're interested in. And but what I want to do here is tie this idea of translation to what you've recently learned about circles. And so, for example, first you learn that the equation of a circle with center at the origin is pretty friendly. For example, suppose this circle has radius of 4 and center at the origin. Then what's its equation? Its equation is x squared plus y squared equals to 16. 4 squared is 16. But if I take that circle and move it somewhere else, suppose I centered it at this point here, and it has radius of 4. Well, pretend that has radius 4. You'll get the idea. So here's the center is at, again, 1 minus negative 2. And if the radius is 4, then what's the equation of this circle? Well, you learned that equation would be x minus 1 quantity squared plus y plus 2 quantity squared equals to 16. So look what happened there. When you learn about circles, you learn that there's a sort of opposite reaction here. In other words, x minus 1 means that the center of the circle is at positive 1 in the x direction, and y plus 2 means the center of the circle is at negative 2 in the y direction. But notice how these are literally translations, a horizontal translation and a vertical translation. So if I took this circle and replaced x with x minus 1, then I shifted it to the right by 1 unit. And if I replace y with y plus 2, I shifted down by 2 units. Now I realize I drew a bigger circle, but this is supposed to be the same size circle. Okay, so I didn't draw it to scale. If we wanted to change the size of the circle, that would be a different kind of transformation. So now circles, you should all recognize, are not functions, but we can still discuss horizontal and vertical translations with them. They still obey the same type of rules. So, all right. So those are the translations, and those are the probably the simplest transformations. And let's move on to the stretches, the vertical stretch in particular.